You're
No,
not
I'm
comparing it against. You're not comparing it against something. Listen, why are you interrupting me? Why are you interrupting me? Why are you interrupting me? You're not comparing it against something in your memory.
I am, though.
Oh, you remember seeing the Earth from that point of view?
I remember seeing rocks, rivers, clouds.
You can't see
nature.
rocks from space, brother. Okay?
I'm talking about real life.
You can't see rocks from. You can see rocks from space now.
No.
Well, you
what?
can see Jupiter, you can see Mars, you can see the moon.
Yeah,
They
so
all
what?
look like globes,
So
or
what?
they all look like spheres.
So what?
So the best presumption would be that we're also on a sphere.
No,
Okay.
it wouldn't.
What would the likelihood be that
that would be
everything we see in
irrational.
space is a sphere?
That would be
Yet
irrational.
we're on something
That
that's
would
totally
be
flat.
brother. That would be
No,
irrational.
it would be totally
It
the
doesn't
logical
logically
assumption.
follow. Okay,
It does.
listen,
Everything you see with your telescope is a sphere.
So
Yet
what?
you assume that you're on something flat. That's
No,
illogical.
it's not an assumption.
It is.
No,
It
that's
is.
what we observe.
It's an assumption.
No, it's what we observe.
Well, what happens if you measure the
Yeah,
angles
so
of
don't
3
adjust
points
that, right?
on a
You're going to say
sphere?
it's an assumption, then you're going to run away from that. So really simple.
No,
Let's go
I'm not
back
running
to the-
away. I'm right here.
No, we're going to go back to. You're running away from your argument. So we're going to go back to the shit's a sphere in the sky, therefore Earth's a sphere. So my statement is: I look in the sky, I see spheres, therefore Earth is a sphere. Is that a logical statement?
Well, it would be very likely, and then you do further experimentation.
No, what's the basis of your likely
and then you realize,
statement?
yes, it is.
What's the basis of your likely statement?
Because if everything you see is a sphere, the likelihood is that we're also on a sphere.
Okay,
and when you do further experiments, you see that we are on a sphere.
Okay, that's cool. This argument reduces to an absurd conclusion. Because if I'm in the woods and everything I see is a tree, that means I'm a tree.
You're literally using the same examples over and over.
Oh my goodness,
He
mate.
said
Shush.
likely. And he
Just
said
stop
that we
talking,
do further
dude.
experiments.
This subject's beyond you, bro. You can't even handle basic shit. Now you're going to adjust what I said, that your faulty logic. It's a non sequitur fallacy. It does not logically follow. Okay? In order to conclude the Earth is stop talking. So in order to conclude the Earth is like the things in the sky rationally, you would have to have noticeable similar properties. Things you see. I look in the sky, I see something on the moon, and I see things on Earth that look like that. So maybe they're the same thing. Can you give us an example of something that looks similar on one of these planets?
Yeah, mountains, ravines.
You can see
have them on
mountains.
other planets. You can see them through telescopes. We also have
You
them
can
on
see
Earth.
planets through a telescope. You want to bet on that?
Yes, you can look at the moon. Okay, we'll call them large craters, call them mountains. You see them on the moon through a telescope.
You don't see mountains on the moon through a telescope.
Well, I said you can call them large craters. What's the difference between a large crater and a moon?
Then, so you were just wrong.
Well, it depends what you want to call them.
We're looking but what are we doing here? We're looking for something that's similar to Earth.
Something that's similar to Earth would be the moon.
Yeah. Ugh, that would be circular logic, though, wouldn't it?
If you were standing on the moon, do you think it would look flat?
Oh,
You're not, though.
How
okay.
do you think the moon would look if you were standing on the moon?
First of all, you're assuming the Earth is like
you
the
think you would
moon.
fall off the moon?
You're assuming the Earth is like the moon. You're getting bricked. Your brain is starting to frizzle frazzle. Okay, really simple. We're gonna stay on this. The Earth is a sphere because the moon is a sphere. What is the logic behind that?
The logic is what I've already explained. Is if everything in space looks like a sphere, then you might wonder, maybe we're on a sphere. Let's do experiments.
You might wonder,
But every time I try and tell you about the experiments, you cut me off. Let's do experiment.
No, the thing is, you were asked to justify your first statement. You failed to do that, and you always twist and say, well, that makes you just wonder. That's not an argument.
Same thing all along. Everything in the sky is a sphere. That would mean we could assume that we're on a sphere. Shall we check? Let's do experiments. Oh, yes, we are.
Yes. Hold on.
When you measure 3 points on a flat surface, the angles equal what?
Excuse me. Hold on. You are correct. If we're going to assume the Earth is most definitely check Now you're going to start rambling off. Let's slow down a little bit and let's figure out what we check, how we check.
I don't like you saying I'm going to be rambling. I think you're rambling now.
Dude, we're going to stick to what we're going to do next. So let's slow down a little bit. Carry on. Let's talk about those angles again. You were mentioning triangles.
You're breaking up. Did anyone hear what he said?
Yeah, he wants to talk to you about these angles and how they're measured. Are you able to do that?
Okay. Yeah, sure. So 3 points on a flat surface, what do the angles add up to?
3 points on the flat surface. The 3 points that are connected by straight sides. You're talking about a triangle.
There you go. And what do the angles add up to?
180 degrees. When you measure the interior angle.
You're breaking up again.
All right, somebody else do it.
Can anyone tell me what he said?
I could hear him just fine.
He said
He's just
180 degrees. Yeah,
Okay.
Yeah.
And if you add up those same points on a sphere, would it be greater or lesser than 180 degrees?
It wouldn't be an angle.
Well, you're begging the question of a sphere in the first place. Where did you go measure this?
What's the definition of an angle?
You have 3 points in straight lines. On a flat surface, it's 180 degrees. On a sphere, the angles are greater. That's how you know you're on a sphere.
Not angles, they're curved lines. What's the definition of an angle?
No, not a curved line. We're not talking about the curvature of the lines. We're talking about the angles from the points.
Okay, what's the definition of an angle?
Can anyone hear him? He's breaking up.
You don't understand what an angle is. What's the definition of an angle?
I can hear everything Jedi says just fine. I don't know.
I hear him perfectly. I don't know what kind of obfuscation this
He
is.
said, "What's the definition of an angle?" Can you?
It could be a connection. Remember, sometimes people have weird connections between each other where they can't hear.
That's true. That's true.
So if one of them.
Yeah, I'm in Hong Kong. Maybe that's why.
Yeah, could you drop off and rejoin and Jedi do it also? It should fix it.
Maybe did like first definition of an angle is, as I'm reading, the space between two intersecting lines or surfaces at or close to the point where they meet.
You were roboting that time, so I'm guessing the connection issue is on your end.
Yeah, he roboted for me too.
How am I coming through?
You were coming through
Yeah,
fine the
because
whole
you cut
time.
out.
Hey,
I was-
HK, can you just
I was
leave the
kicked
chat?
out of the group.
Just leave for a
I
second,
was
come
kicked
back
out
in.
and
See
I'm
if it
back.
fix. Okay.
I already did. I'm back in.
Okay. Cool. All right. Now read the definition out again.
Okay. The space between two intersecting lines or surfaces at the point where they meet.
These lines, are they straight lines?
So we all know, right? If you add up the angles of 3 points on a sphere, they're greater, which shows you you're on a sphere.
So are the angles curved lines?
Hello?
Yeah, those lines for an angle. What's the definition of an angle?
Okay, but we just went through the definition of an angle.
Yeah,
But let's just get to the point.
Okay, good.
Have
So
you
we went
guys
through it.
actually measured on this
Listen to
experiment?
what you said. The intersection of two straight sides meeting at a vertex, right? Where you can measure the separation, like with a protractor that has radial lines coming out from the middle of those straight lines. You're talking about measuring angles on a curved surface. Well, these are no longer Euclidean triangles. You're going to have to prove that we don't use Euclidean triangles on the Earth. We use Euclidean 90-degree right-angle triangles on the Earth to measure elevation and depth.
And if you use them to measure a triangle, what would happen?
We get to where we're going because we use that right-angle triangle to navigate, demonstrating that the surface of the Earth is the horizontal adjacent of the elevation angle triangle that we measure. You're starting to
So
suppose that
pilots
we can
don't need
put.
to
Hold
account
on,
for the
my
curvature
friend.
of the Earth when they plan their routes.
Hold on. You were begging the question earlier that was pointed out, talking about spherical triangles on a sphere. And if we do this, okay, let's see if we do. We don't. We use 90-degree triangles. You know what?
Well, if you have 390-degree angles on a curved surface, they won't meet.
You can't
They
have
won't meet up.
90-degree angles on a curved surface.
Exactly.
Yeah, but we have 90-degree angles on the surface of the Earth when we do things like triangulation, trilateration, navigation, and charting. You know what a 90-degree right angle triangle is, right?
No, I don't.
Okay, so it's an intersection, let's say, of a horizontal and a vertical, and the meeting of the hypotenuse by the extent of those two lines. So 90-degree in one angle and 45-degree in two other angles. Doesn't have to be that way, but primarily that's what it is. So the intersection of three straight sides, right? You know that we can use this right angle triangle to measure either the height of a mountain or our distance to it, but just using a very simple trigonometric formula.
Yeah, but that's
Good.
not measuring a triangle flat. That's talking about one going vertically. We're talking about one going horizontally over the surface.
Hold on. The baseline of the triangle, the adjacent, is on the surface of the Earth. We're measuring the length of it. We're also measuring two angles from that straight line. The 90-degree angle, the base of the mountain, and the elevation angle that you will measure to the top of that mountain. That line between you and it is a straight line distance that you probably want to measure. If you want to figure
But
out...
it won't be a straight line because you'll end up going through the Earth.
Pardon?
If it was a straight line, you'd be ended up going through the Earth.
No, the Earth isn't curved. We measure along a horizontal Earth to do this, mean sea levels, navigation at sea. You're begging the question about spherical triangles, and when we use them, when we use 90-degree triangles on the surface of the Earth, both in elevation and azimuthal, that's a 360-degree directional north, south, east, west circle around the observer. Those are horizontal bearing angles too. East, for example, is 90 degrees from north. So straight lines, angles everywhere. Welcome to flat Earth. That's what we measure.
Okay. Maybe I can just put it in more simple terms. Give me 20 seconds, and then maybe we can move on to somebody else. Cut a piece of paper out into a triangle shape.
Okay.
Put it on a flat surface, and it will be flat. Put it over a sphere, and it will collapse on itself. It cannot be flat on a sphere. That shows you that the angles cannot add up to the same as they were on a flat surface. That's all I'm saying. So all you need to do as a simple experiment is you do something similar to that on Earth over some far distance, obviously, because Earth is big.
We do, I just told you.
Well, you've done that experiment.
Yeah, azimuthal angles. They're called bearing angles. You know, when you go from one place to another?
Yeah.
They're all angles. Right. Based on 360-degree circles around the observer, or 100-degree arch over and above the observer from one horizon to the other, where 90 degrees at your zenith. Like a protractor around the observer. Protractor measuring straight lines and the separation between those straight lines. You like being at the bottom of that protractor on the horizontal line and pointing at, say, a star and measuring the elevation of that star above the horizon, which is above the horizontal plane, and then figuring out your distance between you and the ground position of that object. It's all straight line.
You can do that on a sphere or a flat surface.
No, you can't, because you can't measure angles on a curved surface.
Well, you can if they're just directly in front of you and going above you.
What are you talking about, dude?
Well, you can put a triangle on top of a circle.
The GP of the star you're looking at is sometimes up to 1,000 miles away from you.
Okay, I'm a little bit lost by your last comments, but I will just say that with the piece of paper experiment is a simple analogy.
We know, we get the analogy. What I'm pointing out is when we actually go and measure the Earth, like you're telling us to go and do this. When we do, we figure out that the Earth is measured flat because we keep using the Euclidean geometry to measure everywhere and travel everywhere. So when we do what you say, when we do what you say, we use a flat Earth. We don't measure not 180-degree angles within the measurements of 3 points on the surface of the Earth.
I mean, I'd have to verify it. If you can show me a video or some source where the experiment's been done,
It's called
I'll have a
celestial
look.
navigation. Navigating around the Earth. Also, if you want to look up surveying and measuring the land, you can look at the US Geological Society when we talk about measuring things like altitude and depth from mean sea level. Yeah, it's all horizontal reference.
It has to be over a large distance for it to
when
have
we
an effect on the
navigate,
angle.
dude, when we navigate across the Earth, that's a large distance. We can take one measurement over 1,000 miles. In actual fact, that's being kind. It's really about 3,000 miles. One elevation angle measurement to a star in the sky can give us a distance up to and including and beyond 3,000 miles. Straight line distance between you and its ground position. Yep.
Well, I'm
You
not
brought up
knowledgeable on
triangles,
that
dude.
subject, so I'm going to need to have some time to go and look into it.
Awesome stuff. No worries. Do you want to link to our server? There's a bit called Celestial Navigation and all of that type of stuff.
Yeah,
if you want
sure.
to start research.
Okay, I'll have a look at that.
Cool. Just click my name. The server's there.
I don't know how to do that.
What? Click my name.
Yeah, I only just downloaded this app.
Oh, okay. I'll tell you what, dude. Who am I speaking to? What's your handle?
Hong Kong Musician.
All right, dude. Give me a moment. I'll send it to you. All right.
Thank you very much.
Dude, so I tried to send you the link to the server. I sent you a friend request. It looks like you have to accept the friend request before I can send you anything. So if you want to do that, send me a message. You usually find it in notifications or in your DM somewhere. Should be a notification bell.
Okay, my friend. Oh, I see. Jedi.
Yeah.
Okay, thanks very much. Nice talking to you. And
No worries.
I'll have a look at it. Thanks for sending it over.
No worries, brother. Take good care.
You too.
It's always fascinating when new people come in. It's always good to have the conversation and the chance to have the exposition from a flat earther's point of view. So always appreciate the conversation. If anybody else wants to chime in, like I said, the floor is open. I'll mute your mics and we can say hi and meet each other. It's good to see you in here as well, Crit. I was wondering where you were.
That was a good turnaround with that last guy. He came a little bit hot-headed and left very polite.
Yeah, man. He's still here.
Oh,
I think he's just
it's
still here.
good. It's good when it's good when a conversation sort of starts off like that, and then after a bit, it's like, all right, well, these arguments do actually make some sense. So look into it, as Eddie Bravo says. And HK Hong Kong Musician, if you're still here listening, when you get to the home server, I suggest you check out the Long Distance Observations channel as well. It's one of the best ones, in my opinion. Tons of observations that are literally by magnitudes impossible on a globe. Did HK Musician have something he wanted to ask?
Yeah, I have a question. Thank you.
Yeah.
I'll just preface by saying I'm not here to try and rebuke what you're saying or to antagonize. So this is just a genuine question, if you have time to answer. What my question is regarding things that orbit the Earth, like satellites. The explanation of how things orbit, I think, is quite a simple and quite a nice explanation. And the most simple form I saw of it was that Imagine you, say for instance, you're standing on a mountain, it doesn't need to be, and you throw a rock, it will go some distance and fall. If you threw it harder, it would go a further distance and fall. And if you could throw it hard enough, it would fall at the rate that the Earth actually falls away from the curve, because the Earth is a sphere. So the rock would actually fall. As the Earth fell away, it would continue going and going around. That's kind of a simple way that scientists explain how things orbit. So from a flat earther's point of view, have you got your own theory on how things orbit? And that's a genuine, curious question for you.
Well, first of all, that explanation you gave us about things falling around the ball has already been falsified because the ground lacks any curvature required to be a ball to fall around. We don't need to make up any reasons or excuses for why things appear to move around other things in the sky. We cannot verify how the satellites actually operate. We cannot go up there and test them. And so all of that must be taken on faith from the space agencies. And like, you're free to do that, but we don't have to do that when that contradicts observable empirical reality. And you can go test it for yourself and then also not have to believe it.
So yeah, I'm not sure if anyone's explained this to you yet, but we're not claiming that the Earth is like a flat disk planet floating around in the heliocentric version of outer space.
Okay.
So that's when we're talking about flat Earth, we're not talking about literally comparing like an object, which would be a globe Earth, to like a flat object. That's not the context that we're using when we talk about a flat Earth. Now, when we say flat Earth, we're just talking about the surface area of Earth that we can test and validate. It doesn't have any curvature over distance. We're not claiming to know the shape of the Earth. And we're also not trying to fit the flat Earth inside of the heliocentric version of outer space. So it would be completely incompatible. So when we go out and test the Earth, right, we're testing like the mathematics that are given to us by the globe side. So if we go to a 20-mile lake, for example, we can validate that it's 20 miles across the lake. We can do the math. Now, according to gravity and the globe Earth model, based off the radius value, 3,959 miles, over 20 miles, there should be about 260 foot of curvature, approximately. Now, we can start performing different types of long-distance observations and laser tests and all kinds of different tests to try to find that curvature. And what we've found is that we continuously find zero curvature over those distances. For example, we can set up a camera on a tripod and zoom in over a 20-mile lake and see the shoreline on the other side of the lake. Now, that's not possible if the Earth's a globe. Like, you would have to have a horizon at a certain distance, depending on the observer height, and then the shoreline on the other side of the lake would obviously be hidden behind the horizon, and you could calculate it. And I think, over that distance, it would be a couple of 100 feet or more, a little bit more than a couple of 100 feet that shoreline would have to be obstructed behind. Now, we've repeated these tests over and over again in all sorts of different locations, and we can't find any curvature over these distances. So that's kind of what we're getting at when we say flat Earth, right? Just to give you a better idea of what we're actually claiming here. So I would say the Earth is a topographical plane. Topographical plane, it doesn't move. And the celestial bodies, like, we don't try to make claims about things that we can't validate. So something that's too high for us to actually validate empirically, we'll admit what we don't know and what we can't validate. We don't try to have a replacement for every single claim that the heliocentric model makes about outer space and that kind of thing. But we do all observe the same thing, which is that the celestial bodies in the sky, right, they appear to move overhead in particular paths and reset, after their cycle. They go in cycles. So, yeah. I mean, that's just a basic rundown.
Okay, thanks for explaining. I don't like to be the guy that comes in and just says, what about this, what about that, what about this? But I do have another question. I don't know if you care for these questions. I guess you enjoy talking about this stuff, which is why we have a
Well,
Discord.
Yeah.
So
That's why we're here.
shall I go ahead with the question?
Please do.
You talked about the horizon, there not being a curvature in the horizon. But when you go to the beach, you see the edge of the sea. You see the horizon of the sea. You don't just see all the way to the next country. So what's going on there? What's the difference between what you said and when I go to the beach, see the edge of the sea?
DJ, rock, paper, scissors.
Yeah, well, I've got like 30 seconds left in a chess game, so if you could take it, it would be great.
Okay. You can hear me okay though, mate, yeah?
I can, yeah.
Cool, good stuff. All right, the horizon, good question, right? When we look at the horizon, when we're on a ball, we're told that the horizon is the curvature of the Earth. When things like ships go over the horizon, they're going over the curve, so we can't see them when they go beyond the horizon, right? That's pretty much what you're saying, yeah?
Yeah, because you can kind of see the sea ends at a certain point when you're standing at the beach.
Yeah,
Because
cool.
you can't see anything too further away. Like you can't see the next country.
Okay, gotcha. So is that just with the human eye, right? When you go down to the
Yeah.
beach and you look with your eyes. Okay, what happens when you change the optic, like get some binoculars out, a telescope, or like a high-powered zoom camera? What happens to the horizon then? Do you zoom in on that horizon curvature of the Earth like you would do like the top of a mountain?
I
Where does
haven't
the
done it, but
horizon?
yeah, I guess so.
Yeah, the horizon keeps getting further backwards. Because what the optic does is it increases the ability to increase the angular size of the things that you're looking at, like the surface of the Earth, for example. So with this distance, when the optic, the camera, opens up those angles, it becomes more resolvable to you so you can see it. So what the horizon is the limitation of the optic. So when you, with your eye, based on the human eye's angular resolution limit of 0.02, when you go down to the beach from 6 foot above the surface of the Earth, to you, the horizon appears approximately 3 miles away. Change the optic, the horizon moves. So that in itself should not happen if the surface of the Earth was curved and that horizon was physical Earth curvature. We can also expand on this, right? We can make general assessments as to the distance to the horizon. We can use like landmarks or things that are known distances from the observer out at sea, like oil rigs or lighthouses. So if we're on a sphere, and like you said, when you go down to the beach, the horizon should be 3 miles away. That's based on the calculation 1.225 multiplied by the square root of your observer eye height in feet. 6 foot gives you about 2.8 miles. When we compare that geometric Earth curve model to reality, what we see is a horizon well in extent of that distance. For example, we can show you oil rigs that are approximately 6 to 10 miles away, where the horizon should be at that 3 mile distance, and the horizon is beyond the oil rigs at a safe estimated distance of at least 10 miles. Can be further if you improve the optic, can be further if the weather conditions change, can be less if the weather conditions can change. But that just shows us that it's the angular resolution of the optic and the atmospheric conditions as to where the horizon is going to appear to be. It's not curvature of the Earth, dude.
So you're saying it's a visibility issue?
Yeah, the horizon
Basically.
is purely optical. It's based on the human eye or the optic, right? The ability to resolve the angular sizes of objects at distance, right? That's how we see things get smaller in the distance. We can't resolve the entirety of the surface of the Earth. We can only resolve a short distance, right? Until we improve the optic, increase the angular size. So yeah, the horizon is purely optical. It is also, of course, meteorological. right? We're looking through lots of atmosphere, and the atmosphere causes disturbances, right? Because of different densities, different pressures that we're looking at, and they could be in different gradients, rising, lowering, whatever. Mirages, these types of things happen. But yeah, purely optical. The curvature of the Earth isn't actually physical, dude. It's not there. You're going to need curvature of the Earth for the Earth to be a ball. First observation, we don't see it. Second one, when we can make safe estimations to the horizon, we're not starting to measure it. When we think about what we're doing, we're looking over a surface of water. We understand that water, that lays horizontally when contained and at rest. It's supposed to be curving around a ball. Now, we understand that when we are to be level with the world, we use the horizon to do that, because level, horizontal, a straight line from left to right, is parallel to the plane of the horizon, so you are level with the Earth when you put up your shelves or you hang your picture, right? So to be level with the world is to be level with the surface of water. Water is 70% of the surface of the Earth, therefore the Earth is horizontal, not curving.
So, if we stood at, say, Plymouth, are you saying that potentially we'd be able to see America if we had good enough visibility?
Too small.
Yeah. So a few things, right? One, the angular size and the distance is too small for any optic that we have. But hypothetically, if we had an optic, then yeah, maybe we could solve the angular resolution problem. But we're looking through what, 3, 4, 5,000 miles of atmosphere. The atmosphere is not completely transparent, though, is it? When we look through distance, the mountains far away look duller. They look blue because of the amount of gas that's between the observer and those. So light attenuates through the atmosphere. Eventually, with distance, I think it's about 200 kilometers or 150 miles, something like that, the atmosphere becomes like a brick wall. Light isn't going to pass through it. You're not going to see the light on the other side of it, because it's like trying to look down to the bottom of the ocean. Sun's light doesn't get down to the bottom of the ocean, even though water's transparent, because over distance it isn't. Same with the atmosphere.
Following you.
Yeah.
But how about this as an experiment then? We have a really, really bright light on the coast of America that we zoom in on from the coast
Like a
of
laser?
England.
Like a laser?
Maybe something even as bright as possible.
Yeah, so let's put it like this. We can see as far as the optic and the meteorological conditions allow.
But isn't it the brighter the light, the further that you can see it?
Yeah,
like a candle, you wouldn't see very far away, but a laser pen, you would.
Yeah, exactly. If we collimate the light. Now, we can and have tested that. You're on the right path using this type of thing. So long distance observations, can we see lights at night? Yeah, we can. Shouldn't be able to see them. Can we pass lasers over bodies of water and see if the water diverts from the horizontal line of the laser, like a tangent from a sphere? Doesn't do that. The water's parallel with the laser. This is line of sight targeting that we're doing, right? Line of sight targeting is what the military use and do. So the military use lasers to target things at distance. When we use this straight measure, yes, the Earth is now measured flat. We've confirmed the observations. The Earth measures to be flat. Surveying, dude, right? When we build upon the land, when we want to get level with ourselves from one distance to another. Yeah, when we measure, survey the land, the surface of the Earth is measured flat.
I'm following you and I'm with you, but I just think that the surveying example isn't the best one, because surveying is normally done on too small of a scale.
Well, this is what
we don't have to get stuck on that point.
But that's what we're ideally doing with the laser, isn't it? Surveying the land from one point to another. Level is what we're getting. So I'm not saying that this is what we do within surveying. It is shorter distances, but when we use the technology that's available, still the same principle.
And are there videos showing this?
Yeah, so in the server
that you joined, also in your server?
Yeah, laser tests.
All right, cool. I'll check it out.
No worries, man. Good to talk to you again. I've got to go and
you
put
too.
my dinner on.
Thanks for answering the questions.
Yeah, no worries.
Yeah, I can show you a couple of really good long distance observations in a second if you want.
Yeah, sure.
I'm just.
You know, I'll
I'm
just say that
Yep.
I think the spherical model of the Earth, it makes so much sense when you think about why we have seasons and why some countries are hot and some countries are cold, and why we have night and day, and why the stars appear to turn in the night sky. It makes so much sense that we're on a ball. Although if there are experiments out there showing that the Earth is flat, I'll look into them and I will take them seriously.
Yeah, appreciate it. I mean, I thought the same thing at first, and the more you look into this topic, you'll find that these things can be easily explained on like a flat surface as well. And the more you look into it, it actually does make a lot more sense on a flat surface. But like you said, if the empirical, like practical demonstrations continuously show that there is no curvature, then, that's where I'm going to lean towards. Absolutely.
Yeah, I mean, if the experiments show it's flat, then you have to accept it. But it's just it does, it fits so nicely being a ball with the seasons and the other things. When people hear about flat Earth, it just sounds crazy because everything fits so perfectly with it.
Yeah, we get it's a nice little present that you've got. It's a nice little ball and it explains lots of things. I'll explain those phenomena with 2 words. The sun. You're talking about seasons and day and night. Well, what do we observe? Well, it's the sun doing this because it's bloody hot where we are, and the sun's in the sky a lot where we are. Right? It's closer to where we are. It's hot where we are, but in Australia, it's further away. They're in winter. Day and night, that's when the sun's there. When it's not, that's nighttime. That's how we define it. So it's the sun that does those things. It's not the spinning of the Earth or the motion of the Earth around the sun. It's the Earth underneath the sun, and the sun, moon, and stars doing their dances in the sky whilst the Earth remains stationary. The reason why we have the day and night cycle is defined by the path of the sun across the Earth.
So do you think all the stars are going around the Earth? Or whatever we're on? Let's not call it the Earth.
Yeah,
or whatever it is we're on.
No.
Okay.
Why wouldn't you call it the Earth?
Are
you from somewhere else?
They go overhead.
They go over. But they go down behind the horizon and they come up on the other side.
No.
So are they? Do you guys think that they're the things circling Earth?
No. Right. Just quickly, right? They don't go down below the horizon. That's perspective. When you look down a corridor, right, the ceiling isn't actually getting closer to the floor the further you look down the corridor. That's just the human eye that does that. So when you see the arc of the heavens in the sky, it's just perspective. The same with the sun, why it appears to rise and set is due to perspective. The sun's path is horizontal and parallel to the earth below, but because you, the observer, are observing it, because it's far away and high enough, it appears to come up over your head and then down again. It doesn't actually go down or anywhere though, because we can see the sun for 6 months of the year circling 2 poles in their summers where there's 24-hour daylight. The sun is above the earth. It's just dependent on you and your location of the earth as to what you're going to see the sun doing. It's all going to be based on perspective.
I'm following, and I'm just I'm hearing this for the first time. Okay, so I'll just let you know what occurs to me when you say it. When you see the sunset, the sun still looks the same size, and it just goes behind the Earth. Whereas if it was what you just described, you would see the sun getting smaller and smaller and smaller and smaller into the distance.
Get smaller. Give me a
but
second.
like it would get smaller until a tiny. It would get smaller until it just disappeared. It was so small.
Yeah, exactly.
You know what I mean? It would just become pinpoint.
Okay.
I don't think it does that because you can take photos of the sunset just before it goes. It still looks big.
Okay, now this is going to depend upon your location and the meteorological conditions, because you can take a photograph in, say, Africa, for example, of the sun reducing very much in angular size before it gets anywhere near the horizon and actually fades out into the sky before it touches the horizon. If you were to use a solar filter, for example, you can measure the pixels and notice that, yes, that sun's angular size has actually changed throughout the day. Sometimes it's more noticeable than it's not. If you don't move around and you live in the same location, like I do in the UK, where it's kind of the same, like coldness or whatever, dampness, or we're on an island, we don't really get to see too much change in the sun. We don't really notice it that much. It's too bright to look at half the time. But when it's on the horizon, sometimes it looks bigger than it did when it was in the sky above us. These are magnification effects that can happen on the horizon as well, where the sun looks bigger.
Yeah, isn't that just being magnified through the atmosphere? Or it's like a perspective thing, it just looks bigger because it's next to a building?
Yeah. So there's lots of things that, like next to the building, we don't have a reference with when it's in the sky. So you're correct. There's lots of things, right?
If we're saying it, sorry to interrupt. I didn't mean to interrupt you then.
No, you're fine.
Shall I carry on? But if we're saying it looks bigger on the horizon, I thought it was supposed to look smaller. I thought it was supposed to turn into a tiny dot and then disappear.
It depends where you are, like I said.
Can I jump in just for 1 second? I just wanted to just point him towards the side chat because some people are posting some really cool videos showing the sun appearing to shrink into a little dot as it moves away in these dry environments that Jedi was just talking about. So do you know how to access the side chat, HK?
I'm just looking at it now.
Oh, okay, yeah. Have a look at the one Flat Lloyd posted.
Video,
yeah, and then Dre's posted another interesting one.
Interesting.
Yeah.
Interesting. Okay. Anyway, I'll step out for now, but thanks for the chat, guys.
What size shirt do you wear? We're going to get you your new Flat Earth shirt because when you come back, you'll be a Flat Earther.
I got nothing against it. If I think it makes sense, I'll join.
Yeah, next time you come back, we'll have some more time. I'll go through some of these long distance
Join.
observations.
It's not a club. You're already joined the server.
Awesome. Cheers, mate.
Cheers, guys.
Yeah. Take care, man.